Mars, often called the Red Planet, is a cold and barren world with a thin atmosphere and harsh conditions that make it inhospitable to life as we know it. Yet, for decades, scientists and visionaries have imagined a future where Mars is transformed into a lush, Earth-like environment, a process known as terraforming. This bold idea sparks both hope and controversy, raising profound questions about humanity's role in shaping other worlds. Is it truly possible to breathe new life into Mars, or does this ambition carry risks we have yet to fully understand? The answer remains at the heart of ongoing debates about our future beyond Earth. Mars has fascinated humanity for centuries, inspiring stories in ancient mythology and fueling scientific curiosity in the modern era. Its striking red color, visible even to the naked eye, led early civilizations to associate it with gods of war and intrigue. Today, Mars stands out as the most promising candidate for human habitation beyond Earth. Thanks to its relatively moderate climate, the presence of polar ice caps, and a day length similar to our own. Its surface features, such as vast canyons and towering volcanoes, further distinguish it from other planets. These unique characteristics continue to drive exploration and the dream of one day setting foot on the Red Planet. Terraforming is the process of transforming a planet's environment to make it suitable for human life. On Mars, this would require overcoming a series of formidable challenges. First, the planet must be warmed significantly, as its current temperatures are far below what humans can tolerate. Next, Mars's thin atmosphere would need to be thickened to trap heat and support life, which is no small feat. Additionally, generating enough oxygen for humans to breathe and finding ways to shield inhabitants from harmful cosmic and solar radiation are critical hurdles that must be addressed before Mars could ever become a second home for humanity. One of the first significant challenges in terraforming Mars was increasing its temperature to make the planet more hospitable. Several methods have been proposed, including releasing greenhouse gases into the atmosphere to trap heat and even detonating nuclear devices at the poles to accelerate warming. However, these approaches face considerable obstacles. Mars may not possess enough native resources, such as carbon dioxide or water ice, to generate the necessary greenhouse effect. This limitation raises questions about the feasibility and sustainability of warming the planet using local materials alone. Creating breathable air on Mars presents a significant challenge due to the planet's thin atmosphere and low levels of oxygen. Natural processes such as photosynthesis would take thousands of years to generate sufficient oxygen for human survival. As a result, scientists are exploring technological alternatives, like oxygen generators that extract oxygen from carbon dioxide in the Martian air. However, Mars lacks a global magnetic field, which means its atmosphere is gradually stripped away by solar winds. This ongoing atmospheric loss complicates efforts to maintain stable levels of breathable air over time. Terraforming a planet is a venture that unfolds over immense timescales, often stretching across centuries or even millennia. The transformation of an entire world's atmosphere, climate, and ecosystems cannot be achieved quickly. It demands patience and sustained effort from countless generations. Such a long-term project requires not only advanced technology, but also a profound commitment to stewardship and responsibility. Those who begin the process may never see its completion, entrusting future societies to continue the work. This enduring dedication highlights the far-reaching impact and ethical considerations inherent in reshaping a planet for habitation. Terraforming Mars presents profound ethical challenges, particularly regarding the possible existence of native Martian life. Altering the planet's environment could inadvertently destroy unique organisms or disrupt ecosystems that have evolved over millennia. This raises important questions about humanity's right to reshape another world before we have thoroughly explored and understood its natural state. Should we prioritize our ambitions for expansion or exercise caution to preserve the unknown forms of life that might exist on Mars? The decision demands careful consideration of both scientific curiosity and moral responsibility. Terraforming Mars represents more than a technological achievement. It stands as a profound test of human maturity and stewardship. Our actions on Earth have often led to unintended consequences, raising important questions about our readiness to responsibly reshape another world. Before embarking on such a monumental endeavor, we must reflect on our ability to balance ambition with responsibility. Are we prepared to learn from our past and ensure that our influence leads to sustainable and ethical outcomes? The future of Mars, and perhaps other worlds, may depend on how thoughtfully we answer these questions. In the end, the decision to terraform Mars stands as one of the most profound choices before humanity. It challenges us to weigh the incredible possibilities of creating a new world against the deep ethical responsibilities we hold. As we look to the stars, we must consider not only what we can achieve, but also what we ought to do. The future of Mars, and perhaps our own, depends on the wisdom and care with which we make this choice.